So let's talk about something I'm sure you've run into. You've built this awesome AI, but it really only knows how to follow a script. So how do we get it to stop just following a list of instructions and, actually start making decisions? Today, we're going to do just that. We're giving our AI a brain using conditional logic in LangChain. Look, it's easy enough to build an AI that follows a perfect straight line. Do step A, then step B, then C. But we all know that's not how the real world works, right? The second a user asks something you didn't plan for, that whole rigid workflow just falls apart. We need our apps to be more than just obedient. They've got to be smart. And that is exactly why our AI needs to be able to decide for itself. We have to level up from these simple one after the other chains and start building workflows that can actually adapt. We're talking about creating systems that are flexible, that can react, and they can intelligently handle whatever a user decides to throw at them.
For any AI that's going to be genuinely useful, this isn't just a nice-to-have feature, it's a core requirement. I mean, think about it. Routing a customer support ticket, picking the right tool for a specific task, or even just personalizing a response. In every single one of those cases, the AI has to look at the situation and dynamically choose the right path forward.
Okay, so how do we actually pull this off in our code? Well, LangChain gives us a really specific tool for this job, and it's called RunnableBranch. Let's treat this as our first stop for building decision-making right into the DNA of our AI chains. At its heart, RunnableBranch is a control flow tool that comes from the LangChain Expression Language, LCEL, the whole framework we use to chain our components together. It's basically a big if-else statement for your chains. It lets you say, if this condition is true, run this chain. Else if this other condition is true, run that one. And if nothing matches, run this default chain. Simple as that. And the cool thing is, whether you're a Python person or a JavaScript dev, the pattern is basically identical. You just create a list of these pairs where you have a condition and an action. The condition is just a function that returns true or false, and the action is whatever chain you want to run. And this is super important, you always have to have a default action at the very end as a fallback. So how does this thing actually work under the hood? Well, it's really straightforward and predictable. When RunnableBranch gets some input, it just starts at the top of your list and checks each condition one by one. The very first one that returns true, that's the winner. Its action gets executed, and the whole thing stops right there. If it goes through the entire list and nothing matches, it just runs that default action you provided. Remember that. First match wins. So, RunnableBranch works. It's a core concept, and it's good to understand it. But what if I told you there's a more powerful, more flexible, and honestly, a cleaner way to do this? In fact, the LangChain team itself is now pointing developers in a whole different direction.
Now, this isn't just my opinion. Check this out. This is a direct quote from the official documentation, and it is a game changer. The creators of the framework are telling us straight up that RunnableBranch is now considered legacy. The modern recommended way to do this is with a custom function that you wrap in something called a RunnableLambda.
Okay, so what does this recommended approach actually look like in practice? On the left, you've got the RunnableBranch structure we just talked about. But look at the right. The exact same logic is now just a standard Python function. See how much cleaner and more familiar that looks? All your logic is right there in one place. You just write your if-else logic like you always would, and then you wrap that function in a RunnableLambda to make it a seamless part of your chain.
So why is this new way so much better? Well, for starters, it's way more flexible. You can put literally any logic you can dream of inside that function. It's also just easier to read and maintain because you're looking at plain old code, not some special framework syntax. And honestly, it's just more powerful. You can run complex calculations or make multiple checks before you ever decide which path the AI should go down.
All right, this is where things get really fun. Once you get the hang of this RunnableLambda routing pattern, you can start combining it with other powerful LangChain tools to build some seriously sophisticated AI workflows. Let's walk through a practical example. Imagine you're building a system to process user feedback. If someone leaves a short one-sentence comment, maybe you just need to check the sentiment. But if they write a whole 5-paragraph essay, you probably want a full workup, sentiment, keyword extraction, and a concise summary. The goal here is an AI that scales its effort to match the complexity of the task. And this is just a beautiful illustration of how powerful composition is in LangChain. Your RunnableLambda function simply checks the length of the text. If it's long, it returns a RunnableParallel component that fires off all three analyses at the exact same time. If it's short, it just returns the simple sentiment chain. And just like that, you've made your application both intelligent and incredibly efficient. Okay, one last critical little tool you need in your belt is Runnable Pass-Through. You'll run into this situation a lot. Your routing function needs the original input to make a decision, but the final chain that gets selected also needs that exact same input to do its job. Runnable Pass-Through is a simple little component that just acts like a transparent pipe. It passes data through completely unchanged, making sure you don't lose important information along your chain. It's the glue for a lot of advanced patterns. So, we know RunnableLambda is our new best friend for conditional logic, but let's zoom out for a second. Where does it actually fit inside LangChain's entire set of tools for routing? Because there are a couple of other important ones designed for very different situations.
Okay, here's the breakdown. First up, you've got RunnableLambda. This is your go-to for pretty much any conditional logic inside a standard one-way workflow, where data just flows forward. Then there's a router runnable, which is simpler. You use this when a step before your router has already made the choice for you, like an LLM that says, use the search tool. And finally, for the really heavy-duty stuff, when you need loops, memory, and true agent behavior, you graduate to a more powerful library called LangGraph.
So let's put this all together into a simple cheat sheet. This is your decision-making guide. For basically all standard routing in a normal forward-flowing chain, RunnableLambda is what you want. It's the recommended default. If another part of your chain has already picked the next tool by name, you can use the simpler router runnable. And the moment your application needs to think in circles, remember things, or act like a true agent, you know it's time to bring in the big guns with a LangGraph. So there you have it. You now know how to build AIs that can think on their feet, move beyond simple scripts, and build truly intelligent applications that can adapt to the real world. So the only question left is, what incredible problems are you going to solve with this?